think it's recording now. So this is the MATLAB program that I wrote for taking an LSV and outputting an ESW. It's essentially just linearization, and it's if you look through the comments, it's just picking bounds, and then it's setting up where your y equals mx plus b, and then plotting functions. So it's some pretty simple stuff. I'm just throwing it all into code, which is the cool part about all this. For all the purposes that you would need to use this program, you only need to know that this one's the one you need to use. I have it set up as v3, but I'll probably rename it to the final program. And now let's get into how to actually use this program. So first things first, you want to click up in Home, and also you want to open up MATLAB, which is going to be right here. If you see that on the screen, it should just be on the desktop. You open up MATLAB, it should pop up this, and then you're going to go to Home, Import Data, and then it's going to pop up another screen, and I'm just waiting for that to pop up right now. Then you can go through whatever your data is. Mine is Ethan, and then I'm going to select, let's go with one of my different thickness samples. So let's choose the LSV for the small, or I want to do small Packham. And then one of these guys is the quiet time. So you do not want to click the quiet time. You want to click the actual one, because the quiet time only has 5 data points. And then you're going to open that file, whichever one you want to open. It'll bring up this menu. Wait for it to load the actual table. And then now that you have your actual table of every single data point for that LSV, double click here and retype in data with a lowercase d, otherwise the program won't work. Import selection. And then you can minimize this or close it. I prefer to close it. And then you see in the top right here, you have workspace data, and it's a 995 by 9 table. And it's going to take all of this data, look at it, and look through the names of everything. And the main thing is you need to rename the first thing to data, which is where this first line comes in. So, and the only things that we need to worry about from this point on are these lines of code right here. This is your x values, so your first data point to your 100 data point, or number 100 data point, and this is your y values first data point to your 100 data point. What you need to do is you need to linearize this section. So these two should always have the same bound. So it should always be 1 to 100, 1 to 100, or 2 to 250, 2 to 250. Whatever you want that to be for whatever you're linearizing. And this is going to be your left-hand side, this is going to be your middle side, and this is going to be the far right side. So currently, I think that this is just a good general starting point what we have right now. So I'm going to hit run, and I'm going to hope that it's going to look fine. This might pop up every once in a while. It doesn't really matter. I'm going to change the folder, so. And then it's going to go through and go through all the data, and eventually we should have a few things pop up once it's done interpreting everything. Here's your x-intercept, here's your y-intercept, or your x-intercepts, sorry. After that long wait, here we have the LSV is this purple line. Your middle section linearization is that blue line, your right section linearization is this orange line, and your left side is this green line. The only thing I would change about this one is I would make your your linearization for the left-hand bound slightly longer. So let's go ahead and do that and edit the code. So exit out of this guy, and then we are going to edit this section for the left-hand linearization. It was a little short, so I'm going to say, instead of 1 to 100, I'm going to say the first 200 data points. Well, actually, I'm going to say 50 to 200, so 150 data points between the 50th and the 200th. And as for in terms of voltage, what that's going to look like, that's going to look like 4.5 or negative 4.5 volts to 3.5 volts, or 3 volts, or negative 3 volts, sorry. Um, every single 100 data points is about 1 volt. Just keep that in mind whenever you're editing this. So now I'm going to have to re-import that data, so we're going to have to go through that entire process again. So just to rehash, I'm doing my different thickness samples. I want to do my LSV small pack'em, not the quiet time one. It's going to load in the data table like it did last time. You're going to rename it to data with a lowercase d. Import. Exit out of this guy. And then let's hope that the 50 to 200 makes it look better. And from there, we can take those intercepts. This, I would say, looks a lot better, but now that I'm looking at this middle section, doesn't look the best. I might want to change that also, but this is just a good general start, and you can look at your intercepts here. This one is the negative 3.3, and this one is the 2.99. So we're going to change that middle section to be more representative of the entire linearization. So I think it needs more data points from the left, so I'm going to say 500 to 600. And we're going to go through that exact same process again. It's mostly trial and error. Eventually there might be a smarter program that'll do all of this for you, however that is quite difficult, and if I can get to that level of skill in code, I will. But the more you do this, the faster you get at running all of this stuff. And I would say that looks pretty good. I might do a little bit more, but this middle section's kind of curvy. So I would say this is about as good as it gets, maybe do another 50 data points. But this is going to be very representative of the actual ESW. So for this LSV, or this specific sample, I would say that is going to be our ESW, negative 3.1 to 2.9 volts.